Let's explore solving a linear equation. So let's solve this equation. Let's start with this one. This is a linear, sometimes called first degree equation. What does it mean to solve an equation? What are we to do to solve this equation? Well, we have a variable in this equation, x. And you can replace x by any value. And for example, when we plug in 3 for x, we can see whether the two sides of the equation become equal. So what we want to find are all the values of x, if there are any. There may not be any. Find all values of x that make the two sides equal. Let's see whether 3 is a solution. Take our equation, and we substitute in 3 for x. Let's draw it in green. And then we're asking ourselves, I'll put a question mark here, are the two sides equal? They may or may not be, and we need to check. Let's simplify the left-hand side. 2 times 3 is 6. Let's keep going. It's not clear whether the two sides are equal or not. 6 minus 1 is 5. And it boils down to asking ourselves, is 2 equal to 10? No. This is not a solution to the equation. How about x equals minus 1? Is this a solution? Same process. Here we substitute in minus 1 for x. And see whether the two sides are equal. You see this is a lot of work. And we certainly wouldn't want to do this for every number. Of course we can't because there are infinitely many numbers to check. So we have to come up with a better way than this. But let's go through the steps here. Boils down to asking whether 10 is equal to 10. Yes. This is a solution. So we're asked to find all solutions. And generally, when you want to find the solutions to the equation, this is what we do. Here's the original equation. Let's label it as equation 1. And I'm going to simplify this equation, simplify the left-hand side by eliminating the parentheses, distributing minus 1. So I come up with this equation, which we'll label equation 2. Now these equations are equivalent. There are a number of ways to produce equivalent equations. One is by simplifying, eliminating parentheses, for example, like here. Let's take this equation 2, and I will simplify it more. I will combine the like terms. We arrive at a third equation. And then I can simplify this equation more by adding minus 8 to each side. We arrive at this equation. Which is the equivalent to the third one. Now we can divide, both sides of an equation by the same non-zero number. Here, divide by -2. Sorry, this was +2 here. This was +2. And we get this, equation 5. And on the right-hand side, it simplifies to -1. So now we've come up with the equation 6, the equation x equals -1. And it's clear what the solutions to this equation are. The one and only value of x that will make this equation true is x equals -1. Solution set is just -1. So this tells us that since all of these 6 equations are equivalent, that our original equation has the same solution set. So that too should be our solution set for the original equation. Let's make an important remark here. You need to check. Sometimes, as we'll see later on, the apparent solution may not be an actual solution. And it turns out that -1 does check out in the original. We've, in fact, already done that work.